Scanning electron microscope. We will be discussing about principle, instrumentation, and application of SEM throughout this video. SEM was invented by Manfred von Arden in 1983. Principle. A scanning electron microscope scans a focused electron beam over a surface to create an image, and 3D image is formed. The electrons in the beam interact with the sample, producing various signals that can be used to obtain information about the surface topography and composition. The interaction of electron with a sample resulted in secondary electrons, SE, backscattered electrons, BSE, diffracted, and X-ray generation. However, only secondary electrons and backscattered electrons are commonly used for imaging samples. A random primary electron come from above undergo inelastic scattering to form secondary electron. Meanwhile, when a primary electron that come from above undergo elastic scattering as it reach the shell, it will become backscattered electron. X-ray generation is produced by inelastic collisions of the incident electrons with electrons in discrete shells of atoms in the sample. As the excited electrons return to lower energy states, they yield X-rays that are of a fixed wavelength. Thus, characteristic X-rays are produced for each element in a mineral. Instrumentation. How does it work? The first component in the instrument is electron gun, that is also known as source of electron. Electron current supplied will heat up the tungsten wire for it to produce primary electron. Then, the electron produced will be fired to the sample that you are magnifying. Next, condenser lens. Condenser lens is used to narrow down electron beam given off by the electron gun. It is made up of coils of wire that will create magnetic field and help to narrow down the beam of the electrons. Apertures. Apertures allow you to control the diameter of the electron beam being passed through them. Apertures is a metal rod that holds thin plate of metal that contain 4 holes of different sizes or diameters. The metal plate will also help to block any extra electron that didn't fully condense into the beam from hitting the sample. Scan coils. Scan coils allow the beam to be scanned over the surface of the sample as it controls the position of the beam from left to right. This will allow the information of the defined area to be collected. Next, objective lens. Objective lens is the final lens that focuses the electron beam down onto the sample chamber. Sample chamber holds the sample under a vacuum to eliminate the interference of unwanted particles. Secondary electron detector provides detailed topographical info to user since secondary electron interact primarily with sample surface and have large reflection angle. Backscattered electron detector provides both basic topographical and basic compositional information to user since backscattered electron penetrate further into the material and have smaller reflection angle. Application. In biological science, SEMs can be used on anything such as measuring the effect of climate change of species, identifying new bacteria and virulent strains, vaccination testing, uncovering new species, and work within the field of genetics. Microchip assembly. SEMs help to gain insight into the effectiveness of new production and fabrication method. The potential of complex cell assembling polymers, the high resolution, 3-dimensional capacity of SEMs is invaluable to microchip design and production. Soil and rock sampling. SEMS is used in soil and rock sampling to investigate the microstructure of fine dispersed and finely porous soils such as argillaceous, siliceous, and carbonate rocks. Medical science. In medical science, to determine the cause of illness and measure the effects of treatment. It also helps to identify diseases and viruses, testing new vaccination, compare blood and tissue samples of patients. Semiconductor inspection. The high-resolution three-dimensional images produced by SEMS offers a speedy, accurate measurement of the composition of the semiconductor. So that's all on principle, instrumentation, and application of scanning electron microscope. Thank you for watching!